Now that we've learned what a quadratic function is, this is how you graph one. First off, I'll look at this one here. You have to be able to identify when a quadratic function is in standard form. It's the form that we've seen so far. What is the a value, what's the h, and what's the k? In this case, the a value is 2. It's positive, so I'm expecting the graph to open upwards. The h value, remember that there's a fixed negative here, so this is as if it was x minus -4. The h is -4, and the k value is -1. That -4, -1, those are the coordinates of the vertex. In a case like this, my a value, which is the coefficient in front, is 1. My h is -1, and my k is +1. My hk, the vertex of the parabola, is at -1, +1. So being able to identify the vertex is important because the vertex is a point on the graph. That means that here, let's say, where I have this vertex of -4, -1, that's one of the points on my graph. So I can add that in there, and I can draw in a point at -4, -1, not +1. Put this here, just make that a bit smaller. Okay, so that's a point. That's my vertex. Now what I want to do to be able to fill out the rest of the graph is pick any x I want. But to be able to graph it properly, I probably want to pick x values that are close to my h, close to my vertex. So my vertex here being -4, I'll pick numbers like -3 and -2. They don't necessarily have to be 1 and 2 units away. It'll depend on the scale of the graph. But based on the scale of your graph, you probably want to be close. And I will typically pick 2 points on the same side. In this case, I picked -3 and -2 that are both to the right of my h value. And I'll explain why in a minute. When I plug in -3, it means plugging in an x value of -3, and I'll solve for the y value that corresponds to it. When I plug in x is -3, I'll get -3 plus 4, it's 1. 1 squared is 1. Times 2 is 2, minus 1 is 1. And if I were to plug in -2, I would get -2 plus 4, which is 2. I think I may have said earlier that this was -1 when I plugged in -3. That's not correct. -2 plus 4 is 2. 2 squared is 4. 4 times 2 is 8. And 8 minus 1 is 7. So I've now got 2 other points that I can plot. I have x is -3, y is +1. And also x is -2, y is 7. Now the reason that I picked 2 points on the same side, both on the right, let's say, although I could have done left of the vertex, is because we had said in the intro that a parabola is symmetric. It's the same curvature on the right of the vertex as it is on the left. And so these 2 points here, I can copy them to the other side of the vertex. This point was 1 unit to the right. If I go 1 unit to the left, I'll end up in the same spot. There we go. And the same thing is true for this point here. This was 2 to the right. If I move 2 to the left of the vertex, I'll end up at the same height as well. So this will also be at +7. And if I had plugged in -6, -6 plus 4 is -2. -2 squared is 4. 4 times 2 is 8. And 8 minus 1 is 7. It works. And finally, after I've got those points, I'll draw in my curve as best I can. Okay, I missed this one a little bit. We'll fix that up. And once I've got that drawn, I mean, normally I would just draw this by hand and it doesn't really matter where those points are. That's pretty good. I missed by a little bit. Okay, there we go. And that is how you graph a parabola.